Okay, so hello everyone. Thank you all for choosing to spend the next 75 minutes with us at this virtual workshop entitled Python Basics for Librarians and Archivists. Today's session is number 2 of 4 in a series of workshops on this topic, taking place April 18th, 20th, 22nd, and 25th. My name is Allison Simulevich. I am the Scholarly Communications Librarian at the University of South Florida and a member of the Digital Scholarship Section discussion group. This series of workshops was developed by the DSS Digital Collections Discussion Group, Digital Humanities Discussion Group, and Professional Development Committee in collaboration with both the Equity, Diversity, and Inclusion Committee and the Outreach Committee. Thank you to our presenters, ACRL staff, and DSS committee members for their coordinated effort. In the spirit of encouraging equity, diversity, and inclusion in the DSS community and beyond, I will read a brief statement. Please take a moment and review the guidelines on the slide. We, the DSS community, agree to frame interactions in DSS activities with these guidelines in mind. We recognize that whenever we engage as a community, we will all make mistakes that may unintentionally harm individuals or groups, but we agree to take responsibility for the results of our words and actions. We expect that all DSS meetings will begin with a brief review of these agreements so they may become standard for activities in the section. Next, I will introduce our panelists. Nathan Calvert is the Consulate and Education Manager for JSTOR Labs. He leads community education for the text analysis platform Consulate and is the director of the Text Analysis Pedagogy Institute, a national institute funded by National Endowment for the Humanities. Amy Kirchhoff enjoys her long career at JSTOR, Portico, and Ithaca. She is currently the business manager for Consulate, which offers a comprehensive and easily accessible program that helps you develop text analysis and data mining competencies along with related skills through multiple modes of learning and hands-on application. So please welcome Nathan and Amy. And I'm going to stop sharing my screen and I'll be monitoring chat. So if you have any questions or comments, please use the chat function.
Thanks so much, Allison. That's a great introduction. I'm going to go ahead and start sharing screen and we'll get started today. Now, the assumption for today is that you have joined our first session, but I recognize that there may be some folks that haven't joined the first session. So I'm going to just do a quick review here about kind of what we need to get started here with the Consulate platform. If you have not logged in already, you're going to go to consulate.org. And then you're going to go into the upper right-hand corner here, and there should be a login button. And you're going to log in. It's actually going to take you over to JSTOR, and you're going to use a login there. Now, if you haven't already, go ahead and register for an account. All you need is an email address and a password. And the idea here is that by creating an account, we're able to save the notebooks that you're working on in this class, and you're able to kind of manipulate them and improve them. So I'm going to assume that that folks have got that sorted out. But if you have questions about that, feel free to ask in the chat. Most likely, Amy will follow up with you there. And if you really have trouble, we can also do a share screen and walk you through that process. For folks that are all ready to go, we're going to go into the classes and tutorials at the top here, and then we're going to go into Python Basics 2. Well, actually, I'm going to start with Python Basics 1. We're going to go into 2. You're welcome to click on 2 and open that up. I'm going to start with 1 here because I want to take a look at that and try and answer any questions that folks may have. You'll note here that it's generating my session and opening it up. It may take a little bit longer. We've got about 100 people right now trying to get in. So just be patient. I've also noticed that occasionally the notebook generates too fast. So you may get an error that says something like upstream connect error or disconnect reset before headers, or something that's a little bit confusing. Just give it a couple seconds and refresh, and it should resolve that issue. We actually got a fix for that, but I told our developers not to push it out until after today's class. So if you see that, just give it a couple more seconds and hit refresh, and you should be able to get into the environment.
Hey, Nathan, you already have a couple of specific questions about string, int, and float.
Great. The string, int, and float at the end of Python Basics. Oh, the functions. All right. So this is great because this is what I'm going to talk about. So let me talk about these string, int, and float before we jump into Python Basics 2 today. We've talked about in our first class the 3 data types: strings, integers, and floats. And what we've kind of realized is that they work a little bit differently in Python. Remember, we said that when we use the plus operator with 2 integers or with 2 floating points or floats, that it sums them. That's what the plus does. When we use the plus operator with 2 strings, it doesn't add them or sum them, it concatenates them. It takes those 2 strings and it combines them into one. And so what's happening here in the kind of string, int, and float functions, they allow us to a certain extent to change from one data type to another. Python tries to figure that out intelligently. So if we have something like this example here, and I'm going to make my text a little bigger so it's more readable on your screen. We have something here, and I put, like, instead of this string function, I just put 7, which would be technically an integer. I would be using a string here, an integer in the middle, and then another string on the right-hand side. And so technically, I would be combining strings and integers at the same time. And if I try and do that, Python is going to give me an error because it will only use the plus operator with like kinds, either 2 integers or 2 strings together. And so what the string function is going to do essentially, if we pass the integer into the string function, put it in between those 2 parentheses, it's going to convert it into a string. And that way our plus operators will concatenate all 3 things and give us a nice printout here by concatenating them into a single string and printing them out. And so that's basically the idea behind the string, int, and float. Now, I had a challenge here at the bottom, and I told you what might happen. I gave you a little foreshadowing on Monday, but now I'll work through this and talk through this in case you had trouble with this last challenge. So the first part here is that we have the user age, and we're going to essentially ask the user, how old are you? That is going to be inputted into this variable that we've created here called user age. And then we have, we're going to take the user age and multiply it by 12. And that's going to give us a new variable, the number of months. And then we're going to print out that is more than how many months old. So essentially, we're going to ask the user for their age. They're going to give us the age in years. We're going to multiply that age by 12. And then we're going to print out their age multiplied by 12 to get basically how many months old they are, not to the exact month per se, but just to do a calculation and get some input from the user and then send something back, right? But when we go to use this function, if I say something like, I am, let's say, 25, I wish, then what's going to come out of here is this weird error. It's not going to do, the Python code here is not going to do what we actually want. And it's going to say that is more than, and then it's like some huge number months old. And so we have a bug in our code here, and we have to try and sort it out. For those of you who were able to sort it out, what's the issue that you discovered here? What's actually happening in this code? Go ahead, you can drop it in the chat or go ahead and come on mic. That's fine too. It's repeating 12 times, right? And so you may remember from Monday, I warned you, such a very like foreboding, foreshadowing. I was like, you may get into a situation where a string repeats many times. You may find yourself in this situation. And that's what we can see here. It's the number 25 and it's repeating 12 times. And so what's actually happening here is that when we take in an input from the user, anytime we use that input function, it actually takes it in as a string. Even if it looks like it's an integer or it looks like it's a float, it always is a string. And so we have to keep that in mind. Any input that the user gives us is going to be a string form. So what's happening here when we create our number of months variable is it's taking that string and it's multiplying it by 7 or by 12, I'm sorry. And so what we actually need here is to convert our, to convert our user age into the appropriate format. One way we could do that is with a new assignment statement. So we could do something like this, user age equals, and then we could do str and then user age. And so essentially that's going to say, I'd like to give a new value to user age, and I'd like it to be the old value of user age, but as a string. And so that's one solution. But it's not actually the whole solution, because if I try and run this again, this should give us the proper number of months in our other variable. And I say again, I'm 25. That sounds great. It's not actually going to, I'm sorry. What we need here is an int, not a string. We're getting the same error. If I run it as an int, because remember it's coming in as a string and we need to turn it into an integer. If I run it as an int here, and I say I'm 25, then I'm going to get a different error this time. And that error is actually going to be this line down here. And notice whenever you get an error in Python, it's going to tell you the line where something happens, and it's going to kind of point exactly where it's struggling or it's having an issue. And now it says can only concatenate string, not int to string. And so now we actually have the opposite problem. Our number of months is now correct. But now when we go to put it inside of this other, these two strings and concatenate it, we're trying to concatenate an integer because we use the int function up here to change it into an integer. So one thing we could do is we could simply change it back. We could also just put the str right here. That's another option, I suppose. We could do something like that. Or we could, after that, we could change it back to the other form. So we could do like user age or number of months. I'm sorry, number of months equals, and then we could do another conversion here if we wanted. So that would be, we need a string this time. So we could do string, and then we could do number of months like that. That would be one solution that should work out. And then we don't need a string here. And so if I say 25, that would do our multiplication and it would change how it should. Now, there's actually a lot of different ways that we could solve this and we could make it shorter. But the important concept that I want you to get here is that whenever you use the input function, it's going to give you a string, and that the int, stir, and float functions will help you convert from one data type to the other. That's essentially, that's what I want you to learn from this section right here is those two things, that you can use those functions to change the data type. And also whenever you get input from the user, even if it looks like they're inputting a number, it's going to turn into a string. I should also say you can use this input function in a couple different ways, and I'll preview that right now. So for instance, I could put my prompt separately, and it could look like something like this. How old are you? I could print that out ahead of time on a separate line, and then I could write user age equals input, and then pass nothing in. That will still do the same thing. It's still effectively the same code as before. This code is a little bit shorter because it's all on one line, but you can certainly write it the other way. That's perfectly fine. In fact, I find that this input is a little bit neater because when you do it like this, it puts it on, puts your answer on the next line. So if you look up here for the response, the 25 is on the same line as the question, whereas down here, the 25 is on the next line. That might make it a little bit clearer. You notice if I do it this way, where I pass in the string that's asking the question, I usually put in a space at the end, just so that this 25 isn't hugging that question mark when it goes to get printed out. Little tiny text tips and tricks that you can do. The other thing that I went over fairly quickly in this lesson was the concept of an F string. And I didn't talk about F strings very much, but I want to show you what that is. So for example, we have this line here where I'm printing out that is more than, and then I have a concatenation plus, and then the number of months variable, and then plus months old. That's one way that we can write it. Another thing that we can do is something called an F string, and I'm going to show you that right here. We can do print, and then we put the character F in front. That's what makes it an F string. And then I could say that is more than, and then in brackets, I can put the variable that I want to be in the middle of my string. And so this is called an F string. And you'll see them out there in the wild. So I want to make sure that you're familiar with them. And so that is essentially doing the same thing as the line above. The only difference is it's a little bit shorter because I don't have to use two different plus operators to do my concatenation. I can use this F syntax, and it will automatically insert in the variable into that string and print it out for me. So it can make things a little bit shorter. That's the nice thing about an F string. If you have a bunch of strings that you need to concatenate for your print statement, an F string might make your print statement a little bit shorter. All right, so those are all the things that I wanted to review quickly before we get started today. Amy, did we see any questions that folks had that you weren't able to resolve?
I think we're good. Do you want to confirm? Crystal had a question about whether the error messages are coming from Python or Jupyter. I said I was pretty sure it was coming from Python, and Benjamin agreed, but we can get your expert opinion.
Yeah, they're coming from Python.
Yeah.
You'll get the same errors back. And I hope you took the quiz. It was a little bit tricky. There are a couple tricky questions in there, but if you got them all, that shows that you really, I think, had a firm grasp on what we were doing. One other thing I said I would mention before we get started with today's lesson, I have to mention the TAP Institute, of which I am the director. If you are really interested in continuing your Python journey and you're interested in doing things like text analysis or things, the Text Analysis Pedagogy Institute is a free institute. It's funded by the National Endowment for the Humanities, and we have incredible courses that we're going to offer this summer virtually. So if you're interested in continuing to learn after this is over, I encourage you to check this out and to apply. Let's look at some of the courses just real quick. I teach the Python Basics, but there are instructors, very well-known instructors that are teaching other courses as well. Most of the courses. There's Working with Twitter Data. There's a Practical Guide to Text Data Curation, Introduction to Natural Language Processing with Spacey, Introduction to Multilingual Named Entity Recognition, Web Scraping and Text Analysis in Bilingual Social Media, Machine Learning, Introduction to Pandas, which is kind of like super powered Excel with Python, multilingual newspaper data and visualizations. These are really aimed at kind of higher education and in particularly the library community. I'm going to drop this in here. I have kept the application period open through this week just because I knew that ACRL folks would be interested in this event. And so I want to make sure that I tell you about that because it's free and it's awesome. So, and I think it'll be of use to you. All right, so I'm going to go ahead and click on this Python Basics 2, and I'm going to open up the Python Basics 2 notebook, and we're going to get started there. As I said last time, all of these lessons are Creative Commons, copy left, CC BY. Please use them, change them. The goal is to help people teach text analysis. Amy and I work for Ithaca, and particularly I work for JSTOR Labs, but we're a nonprofit, and we're really motivated by our mission to help higher education and to improve education. So our goal is to create things that help librarians and teachers improve higher education. So, so Python Basics 2, let's jump in and get started. First of all, I also have a video for this content as well. And we're going to jump in with flow control statements. And today is really about kind of adding some complexity to our programs. So far, we've been creating kind of one variable at a time, and we can put one piece of data, a float, an integer, or a string into that. But the question is, like, what if our program has to actually make some decisions about what the user inputs, or what if it has to make some choices? That is, what if it doesn't just go line by line, but it maybe needs to do one thing and then decide to do something else further down? And so that's what we're going to look at today, is kind of a lot of strategies, really. And you don't really need to be able to deploy all of these immediately, but I want to introduce them all to you. I want to make sure that you've at least seen them, even though I'm not going to use them a ton going forward in the other lessons that we're going to do together. You need to know what the kind of flow control options are for writing a program. And so when I talk about flow control, I always use flowcharts because I just think it's a good way to show people what a program is, how it's making choices. And yeah, I sometimes when I get really stumped on how to write some code, I will go back and I'll write out a flowchart first, and then I'll be like, okay, now I know what pieces of information I need and like how the decisions get made. Now I can actually try and translate this into some Python code. So I have an example here that's aimed at undergraduates. And the idea here is the student wants to go hang out and relax with their friends. And the kind of little program here is like, what should they do in order to make that happen? So we have a start here, and then the first thing is a decision. Anytime there's a decision in a flowchart, you're going to see a diamond. And so the diamond here is asking, do you have homework? And if the answer is yes, then you're going to complete a homework assignment. And anything that's like a task, something that needs to be done in a flow control chart, is going to be a rectangle like this. And so you would complete a homework assignment, and then you would ask again, do I have homework to do? And if you have homework to do, then you would just keep doing this loop right here, I guess, until all of your homework is completed. Then you would say, no, I don't have any more homework. And you would check to see, are my friends available? If they're available, you're just going to hang out and relax. And that's the end of our kind of flow here. That's everything you need to do. If the friends aren't available, then you're going to say, well, how social do I feel? What are my energy levels? Do I want to make new friends? If you're feeling kind of low energy, then you might wait until tomorrow and see if your friends are available tomorrow. If you're feeling high energy, ready to make some new pals, you might go to class and ask someone friendly to hang out and see if they're available. And so again, you've probably all seen flowcharts before, but I just want to introduce that because it's kind of like what I'm going to use to explain the logic of the programs as we kind of learn these different methods. So we can think of these yeses or nos kind of like choices, right? And in Python, we would write these not as yeses or nos, but we would write them as trues and falses. We would give them Boolean values. And so we could imagine something like a variable called are friends available, and we could set that equal to false, or make new friends, like would I like to make new friends? I could set that to true, or are new friends available, etc. And so that's the idea, is we're going to start with this just simple thing, yeses and nos, that become trues and falses. And these are a fourth type of data. That is, we've done integers, floats, and strings. I'm going to add in one more. We're going to add these Boolean values. One key thing about these Boolean values is that they must be capitalized. So if you run this code here exactly as it's written, you're going to get an error because it's going to say false is not defined. But if you change this F and false here to a capital F, you'll see, like, watch, it turns bright green, like the color changes. Python is like, oh, green light, I know what this is. You're speaking my language here. I see capital F false or capital T true. That's something I am familiar with. And so when you use the capital letter first, Python will recognize it as a Boolean value. And something important that goes along with this, we looked on Monday on things that were rules. First, there were kind of like soft rules that are like guidelines, and then there were like hard rules, like if you name a variable this way, it will break your code. You can't create a variable called capital T true or capital F false. Python will not like that. You change the nature of true. So you can't do something like this, true equals 7. Python will be upset with you. But of course, we can store, as we've seen, we can store false or true inside of a variable. So I'm channeling Danny Rojas here from Ted Lasso. I've got football is life, and also this is channeling me, tacos are life. And so you could essentially set a variable in there. Okay, so one thing that we have already looked at in terms of making flow control is comparison operators. Remember before we looked at integers and floats, and we decided that Python can figure out that the integer 5 is equal to the float 5.0. We're going to look at those comparison operators again. So in this case, we have 67, the integer is equals to 67. And so that's saying, it's asking Python, it's like a pop quiz, true or false, is 67 equal to 67? And Python is going to give us back true. Now, one thing I want to be very clear about here that often confuses people when they start writing these things, because they're learning assignment statements and they're learning comparison operators, usually pretty close to one another. A comparison operator uses 2 characters, 2 equal signs. If we try and write 67 equals, just 1 equal sign here, equals 67, it's going to think that we're trying to create a variable called 67. And we already know from last time that it's a big no-no to create a variable that starts with a number. And it's certainly, we don't want to be able to reassign the value of numbers in Python. That would create all kinds of weird bugs and problems. So if we try and write 67 with 1 equal sign, 67, Python's going to give us back an error because we cannot create a variable that's just 67. That's a big no-no. So whenever you're thinking of comparison operators, that's going to compare the thing on the left to the thing on the right and give back a Boolean true or false, you should remember that you always need 2 characters to do that comparison operator. And in addition to kind of just checking if 2 things are equal, we can also do things like check if they're not equal to each other, or if they're less than or greater than or less than and equal to or greater than or equal to. I'm going to thank Ms. Reynolds on this one from 2nd grade, who taught me the way to remember this is that the alligator whose mouth is that little carrot right there always eats the bigger apple, the bigger number. That's the ridiculous way that I remember this. So yeah, you're welcome for that. I'm sure some of you went through the same experience. You didn't have Ms. Reynolds, but you may have learned it the same way. That's how I learned it. That's how I remember it, and I'm sickened by it. So I may be a big fancy programmer, but I still see alligators eating apples when I write these. So I want you to try in this next cell, try out the not equal to operator. I'm not going to show you the verbiage because I think you got this, but I want you to try it. Heather says she remembers that Pac-Man. I like Pac-Man. It's a good example. He's eating the little dots for the fruit. Miss Pac-Man, much superior game, by the way. Much better. That's fine. We got 80s kids here. I think if you said Pac-Man today, I don't know that kids would know what Pac-Man was. Maybe they would, I don't know. Maybe I'm the one who's out of touch, but I feel like Pac-Man's not Pokemon. Well, I'm gonna date myself even with that. I don't know what's cool. I'm too old to know what's cool. Minecraft, not sure. Pokemon is still cool. Okay, that's good to know. We're going to try the not equals to operator here. I'm going to do 5 is, and I'm going to do not equal to 7, which in this case is going to be true because they're not equal to one another. And so that's what our check is going to look like. I'd like you also to try here in the next code cell, try doing an equal to operator with a string. Essentially, we can do the same operations with these comparison operators. The only difference is that essentially it's going to go through a string and check character by character, like exactly character by character, to see if there's a perfect match between the two things, right? And so even if there's a stray space or something in there, then technically the strings are different, because a string, you can kind of think of a string just as a series of characters. And those characters, like I said before, could be numbers. The thing that makes it a string is the fact that it has those single or double quotes on each side of it. That's how we can recognize that something is a string. So if we did something like hello, and then we did equals, and then goodbye, like so, we're going to get back false. Hello does not equal goodbye. Those are two different strings. But if I do something like aloha and aloha, then I'm going to get back a true here. So Python identifies those are identical strings, and therefore it's going to give me back a true. Jonathan asks, how do you easily move your cursor past the second quote? So sometimes there's an autofill. Maybe that's what you're referring to, Jonathan. Is sometimes there's an autofill. If there's an autofill on the next character, you can just type the next character the same, and it will easily go past the character that's being populated there. Maybe I'm misinterpreting your question, but if okay. We already tried this on Monday. We discovered that a string cannot be equal to a float or an integer. If we have something like 5, that cannot be equal to, say, 5. That's going to give us false. We can, this is a string with an integer, but an integer can be equal to a float. So if we do something like 5 equals equals and then 5.000, it is able to figure that out. What I want you to try in this code cell here is a little bit of coding. I've given you kind of easily packed examples. Let's see if we can write a couple lines. We're going to use a comparison operator on a variable this time. So I want you to create a variable right underneath this comment here. I want you to create a variable called number of dogs. I have to spread the love. I know that cats are traditionally librarian pets, and I have 2 cats, so I guess that makes sense. But I am also a dog lover. And so I want you to create a variable here called number of dogs, and I want you to do an assignment statement. Remember, 1 equals sign, and I want you to assign a value of 0. We're going to start there. And then underneath the next hashtag here, we're going to check whether number of dogs is greater than or equal to 1. So the first line that you're going to put up there is an assignment statement to create the variable and give it a value. The second line that you're going to write is a comparison operator to check whether number of dogs is greater than or equal to 1. A bit of a review on assignment statements. Also double checking that knowledge about how many, whether an assignment statement uses 1 or 2 equal signs. So we're going to create number of dogs. And I'm going to use 1 equal sign for our assignment statement. We're going to set that equal to 0. Did you get the comparison operator? You didn't, there's the first line. The next line, the comparison, number of dogs, and then we want to know if it's greater than or equal to 1. And in this case, we're going to get back a false. We could, of course, change this assignment statement here to be 1 or 3. And if we do that, then our comparison operator, number of dogs is greater than or equal to 1, is going to return true. Great. Boolean operators. This is something, if you've ever had to teach how to use the library search catalog before, you've had to teach these things. So this shouldn't be too challenging then. We can use Boolean operators, basically and, or, and not, to create expressions that evaluate to a single value. And so I'm going to use just two things here when we're working with Boolean operators. When we use the and operator, it determines whether both conditions are true. And so we're still working in kind of expression land where we write an expression out, then the whole expression is going to be evaluated to be either true or false. But now we're working with kind of two different conditions at the same time. So if the first condition is true and the second condition is true, and there's an and in the middle, then the overall evaluation is going to be true. Now with an and, like I said, all of the conditions have to be true in order to get an overall evaluation of true. So in this example here, I have true and false, and that means the first condition is true, the second condition is false, but I have an and in the middle, which means all of them need to be true in order to give me back a true. So in this case, I'm actually going to get back a false. And I've created a helpful little, it's called a truth table here, to kind of give you an idea of how the and operator works with multiple conditions. Essentially, the only way to get an overall evaluation of true is if to have everything be true with an and. So true and true in this case leads to true. Anything else, if we have true and false, or false and true, or false and false, those are all going to evaluate to false overall when we're using the and in between. Now, the complement to that is the Boolean or operator. And so with or, we only need one thing to be true to get an overall evaluation of true. So we have something like true or false, then the overall evaluation in this case is going to be true. And if we, the only case in which we'll get a false overall is if everything is false. So it's kind of like the inverse. And so here is the truth table for using ors. If we have true or true, we get true. If we have true or false, we get true. If we have false or true, we get true. And if we have false or false, we get false. That's the only time. And so you can see that overall, I'm gonna, zoom out just for a moment. Overall, the ands are have more opportunities to become falses, and the ors have more opportunities to become trues.
Nathan, just a quick question in the chat.
Sure.
So and or not don't have to be in caps with Python?
That's right. Yep. And the other thing I'll add in there into the mix is that we can use a not. So if we have something like not false, it will flip it to true. And I suppose you could write like not false and it will flip it twice. Don't do that, it's bad code. But you could do something like that. Or Python will interpret that. How about that? Python will interpret it. Don't do it. I'm just demonstrating that the not flips. That's all the not does. And so I want you to know that that's a thing. So let's look at some actual examples, and that will help you work with some kind of more realistic examples rather than these very basic ones. So we in here, again, I always seek for clarity. So when I have multiple conditions and they're between ands and ors, I use parentheses because that's a friendly thing to do. So I have put these two conditions in parentheses, and then we're going to evaluate them here. So here we have 3 is less than 22, and we have 60 is equal to 34. So in the middle is an and, which what we know about and is that everything has to be true. So without running this code cell, go ahead and drop in the chat. Do you think this is going to turn into an overall evaluation of true or false? I'm seeing a lot of falses. All right, for you folks that are saying false, why? Why is this going to be false? Right, because both aren't true and the second one is false. So in this case, 60 is not equal to 34, so we have a false evaluation here. That means since there's an and in the middle here, it's going to be false overall. What if I change this and to an or? How does that, or does that change your answer? Now is it going to be false or true? Good. Now it's true because this first example here, 3 is less than 22, is true. And with an or, we only need one thing to be true. We don't have to go any further. We've got one thing that's true, so that the overall it's going to evaluate to true because we have an or in the middle. Let's try the second example here. 3 is equal to 45, or 3 does not equal 7 with an or in the middle. Is that going to be true or false? Good. I'm seeing trues. It's true because this second example here, 3 does not equal 7, is true, and it's an or, so we only need one thing to be true. What if I switch this on the fly to an and? What happens then? False. All right. These can be a little bit tricky if you haven't looked at things like this, but I feel like if there's one community that's probably going to have this, it's library people. So thank you. If you still find this a little bit challenging, practice with it a little bit, and also just run examples and see if you can guess what Python is going to come up with. Okay, so we've got a few things. We've got comparison operators, we've got ands, ors, and nots. We're ready to start writing some Python code that's going to do some flow control. So let's make this happen. I've got a general form here. This is sometimes called pseudocode. It's not like actual Python code, but it's like sort of like it. That's going to kind of explain what the code would look like. And so this is generally how you would write a simple Python flow control statement. It's going to say in this condition, then there's always a colon. Don't forget the colon. And then there's a tab in. Don't forget the tab in, but actually in this case, it will tab in automatically for you. And then the action that's going to be performed if the condition is true. So essentially, we're checking to see if something is true here. If it's true, the thing that's going to be performed is written down here on the next line, tabbed in one time. And so if we have something like the beginning of our flow control or flow chart that I had at the beginning, where we're checking, do you have homework? And if the answer is yes, then you're going to complete a homework assignment. If we were to put that into Python pseudocode, again, not actual Python code, but this is kind of what that would look like. It would be something like if have homework equals true, colon, and then we would tab in, and then we would put in the code for completing the assignment. Okay. And so if the have homework evaluated to be true, then the code down here where it says complete assignment would be executed. Now, this tab here is actually really important. So I'm going to take a moment just to talk about that tab. It's that important. It's a very important tab. And so that tab establishes what's called the code block. And a code block is it's a snippet of code that begins with an indentation. It could be 1 line long, it could be multiple lines long. But the idea is that by indenting one, you're creating a code block. And these blocks kind of form a hierarchical structure in terms of how the code is organized. And so each time you indent, you're creating a new code block at a lower level that is encapsulated by the blocks at the higher level. So I've got this beautiful image here that I created in Microsoft Paint that tries to visualize this. So up here, we can kind of, when we start writing our Python code, we kind of think of starting all the way up and left. And so the main program is kind of to the top and left as you can be. When we go to one indent, we're going to start kind of code block 1. That's a new code block like that we would be starting by indenting. If we indent again, we'd be creating a code block 2. And technically code block 2 would be within code block 1, right? It's inside of, one code block is inside of the other one. We could indent again and create code block 3 and so on. We could also continue code block 1. We could close 2 and 3 by indenting back to the left or dedenting. I don't know what the by tabbing back over and being at the same level of indentation on code block 1. We would be still writing in code block 1 here. So this is code block 1 continued. It's not in code block 2. It's not in code block 3. Those two have ended because we've gone back to the left. But code block 1 is still continuing, and it will only end. A code block only ends when the next piece of code is further to the left. And so that's the concept of a code block. And it may seem that I'm being weirdly emphatic about this, like it's just tabs, man. But in Python, the tabs are important because they determine how the code is run. And so if things are not tabbed in the right way, then your code will break or do strange things. So that's why I'm being so emphatic about, like, this is exactly what a code block is and why the level of tabbing or the level of indentation is important, because it changes the way that the code runs. And so if we look at this example here, the reason why this is important is because anything that is tabbed in here under this complete assignment code, whatever it would be, is essentially going to be what runs if have homework equals true. And so it may be that we need to do 10 lines worth of code if have homework equals true. In that case, all of the things that we need to happen need to be tabbed in. If we accidentally went left a tab, then technically that would be the code that executes after our flow control. And we'll look at examples of that later, but you can see essentially what that means is that any code that is tabbed in goes with this particular expression, this particular check that's being made to determine if the code should be run. That's why the tabbing is so important. So these are the types of flow control statements that I have in this lesson. We're going to go over these together, so don't feel like this should all make sense immediately. Also, we're not going to apply all of these immediately. My goal here, this is supposed to be an overview in this case with flow control. There are certain things I want you to come out of Python basics and be like, I know exactly how to do this. This is more of a, like, I want to make sure you're aware of the most familiar, the most popular options for doing flow control. So even if you don't use one of these right away, you might come to a point one day where you're like, oh yeah, I know Nathan mentioned there was this type of flow control where I could do a try except. I don't remember exactly how that works, but now I can go back and check on that because I need it now. The time has come. And you can go back and take a look. But we're going to look at kind of some of the most popular ones together to try these out. So the most popular one is an if statement. Laura asked a question, once you exit a particular code block, do you ever go back to it? No, once you have gone back further to the left, that code block has been closed and you can't return to it. The only case where that might not be true is if, like, you had an example where we defined a function and the function had a code block in it and we called the function again. We'll look at an example like that later in the week, but the idea is once that indent is closed, the code block is closed and we're leaving that and we're going to the next line and executing what's on the next line. So, so this is an if statement. It looks like this. If this is true, colon, and then we tab in, and then we perform this action. So we can think of a program that looks something like this. Ask the user if they're having a good day. The user is going to input an answer. We're going to evaluate that answer. And if the answer that the user gives us is yes, we're going to print glad to hear your day is going well. And for this example here, I'm just going to show you the code. In a moment, I'm going to have you write some code. So pay attention here. So we can have something like a variable called having good day. And we do an assignment statement with one equal sign. And then the input function, here's the prompt. Are you having a good day? Yes or no? And so the user is going to input an answer here. It's going to be taken in as a string, and it's going to be stored in this variable, having good day. That's what's going to happen here. Now, here's the flow control. Here's what's going to happen with the flow control to determine whether we print out glad to hear your day is going well. If having good day, which is the name of our variable, is equal to, and then here I have the string capital YES, or I'm using an or here, having good day equals the string YES with a lowercase y. So I'm actually checking uppercase and lowercase here. Then colon, don't forget the colon. Then I'm tabbing in print, glad to hear your day is going well. So when I run that program, I can type in yes, and it's going to respond to me, glad to hear your day is going well. What do you think the program will do if I type in no? It's an interesting question. I feel like we got some programming ringers in here. Nothing. It's gonna, you're absolutely right, folks. It's not gonna do anything because I haven't told it to do anything. It's not gonna give us an error. It's just gonna say, oh, having a good day is not yes. It's gonna skip this code block right here. The program's gonna end because there's no more directions. The computer's like, okay, I'm done here, clocking out. And so we need to add a little bit more sophistication. One way we can do that is with an else statement. And the interesting thing about an else statement is it does not actually require a condition to be met to evaluate to true or false. It's kind of a catch-all. And so the else just kind of looks like this. Else, and then there's a colon, and then indented the action to be performed. And so else this is what our kind of new program will look like. We're going to ask the user if they're having a good day. The user is going to input an answer. We're going to evaluate the answer. If the answer is yes, we're going to print glad to hear your day is going well. If the answer is not yes, then we're going to print out I wish your day was going better. Okay. So here's the code from our program already. Right? This is the exact same code that we had above. It's going to check for this yes. What I want you to do is looking at the syntax up here, I want you to write an else statement. Remember, the else statement does not have to have it does not have a test that's involved. It's just else with a colon, and it's always going to run if the first if does not run. I want you to try and plug in an else statement here that is going to run if the if statement doesn't run, and it's going to print I wish your day was going better. All right, it's going to look like this. Else, as soon as I type else, it's going to be in bright green. Python is going to be like, I know this word. And then I need my colon. As soon as I hit return, it's going to recognize I'm doing flow control. It's going to automatically tab for me. And then all I needed to do in this case is print, I wish your day was going better. And it'll run like this. So if I do yes, it's going to say, glad to hear your day is going well. If I run this code cell again and I put no, It's going to do, I wish your day was going better. In fact, with this else statement, it doesn't matter. The only thing we're checking with so far is seeing if this having good day is equal to capital Y yes or yes. So if I type anything but yes, it's actually going to run our else. So if I put like absolutely, which is like a way of saying yes, then it's actually going to check just for yes, and it's not going to find it. And then it's going to run our else statement here. And so it's going to say, I wish your day was going better. It's not going to run, glad to hear your day is going well. So we actually need even more sophistication, I think, to make our program more robust. And so we can use what are called else if, or sometimes this is abbreviated to ELIF, E-L-I-F, to create a kind of tree of options. I like to think of this as a sandwich because everything for me is food. Pandemic has not been kind. And so the way I think about this is it starts with, there's kind of like two pieces of bread. The top piece of bread is the if, the bottom piece of bread is the else. And then in the middle, all of the toppings that are going to go in your sandwich are these else ifs. And this is kind of what the construction looks like. If condition A is true, perform action A. If condition B is true, perform action B. Else if condition C is true, perform action C. Else if condition D is true, perform action D. If none of those evaluate to be true, not a single one, then it automatically is going to run that else, that catch-all. And so it's going to perform action E, in this case, if none of the other conditions turned out to be true and none of the other code was run. Okay, so we can imagine our new program. It's going to look like this. Ask user if they're having a good day. User is going to input an answer. We're going to evaluate that answer. If it's yes, well, we're glad to hear your day is going well. If it's no, we're actually going to check this time. We're not going to just use an else. If it's no, we're going to say, sorry to hear that. I hope it gets better. And then we'll have an else that basically says, sorry, I only understand yes or no. So we're kind of helping our user understand why we didn't get the memo or the message on this one, because we only understand yes or no. And so I've got the first part of the program that we had before, and I've got the else here, printing, sorry, I only understand yes or no. I want you to put the toppings in the sandwich here, write the middle else if statement for having a good day that's actually going to check to see if the user's answer was no.
Nathan, there's a question in the chat.
Yeah, what if you gave them a multiple choice answer? Choose A, B, C, or D. You could do the ELIF statement correct. Yep, you could do the first if would be checking if the user answer equals A, do A. Else if user answer equals B, then do B. Else if user answer equals C, do C. Else if user answer equals D, then do D. And then you could include the else statement as a catch-all, like you please specify A, B, C, or D. It is possible, of course, to leave off that last else. You're creating an open-faced sandwich then, but that's fine if you don't need a catch-all at the bottom. That's also something you can do. Oh, I love it when people ask the question, which is the next thing I'm going to answer. Thank you, Linnea. That's perfect. That's the next thing we're going to talk about, and it's a great question. So let's get the code here. Else if or elif, that's the way we shorten it. Having a good day equals, and in this case we're going to do no, or having a good day is equal to no lowercase, and then we're going to print. What do we want to say here? Sorry to hear that. I hope it gets better. We're going to pass in a string here. Sorry to hear that. I hope it gets better. We don't need 3 T's. All right. Anytime you write your Python code, it's a good idea to do a little bug testing. Make sure everything's working properly. We're going to do yes, and then I'm going to do no. And then I'm going to do fuzzy pickles. And it's going to say, sorry, I only understand yes or no. So code is working as intended. Okay, so then the question in the chat is the difference between else if and if. Why wouldn't we just use if here? And there's a lot of good reasons to use the else if. That is, you should always use the else if you are making a single flow control choice. And that is, if only one decision needs to be made and one thing needs to be done, then using the else if is absolutely the way to go. For one reason, it'll make it clear for somebody who's reading your code. And so if somebody is reading your code and they see if, else if, and else, they will know when they see that sandwich that just one choice is being made, right? And so that's clearer than a bunch of if statements in a row, because each if statement would effectively be a unique choice in and of itself. The other reason to use the else if is because it makes your code faster. That is, using the if, else basically tells Python, as soon as you find something that is true, I want you to do this act. I want you to complete this action. As soon as it finds that true, it runs the code block that is underneath there, and it skips over all the other code blocks. And so if we were to write that all as a big nested bunch of ifs, then Python would have to check all of those individually. And there's a bigger potential too to have some kind of error in there where you might accidentally get 2 truths. And so it's a little bit trickier to write things that are absolutely mutually exclusive to make sure that we're only getting one true. And so by using else if, that shows that it will speed up our program as well. And so, like, I'm going to give you an example here. We're going to make it happen. Let's go back up to this code cell here. And instead of an else if, we're just going to change it to an if, because I want to show you what's going to happen here. And so it doesn't seem like it should be a big difference, but watch what happens when I run this code and it says, are you having a good day? I'm going to type in yes, and it's going to give me a little bit of a confusing output. It's going to say, glad to hear your day is going well. And then it's going to say, sorry, I only understand yes or no. But I typed in yes. You should understand what I'm saying because I said yes. What's going on here for folks who are looking at this? Why is it giving me 2 outputs? It's instead of just the one that I wanted. See if you can suss this one out. Laura points to the else statement. It's running the else statement, but why? Yeah, and Jonathan's putting his finger on it. Thank you, Jonathan. So what's happening here when I do the yes, it's running this first, it's saying, oh, having a good day is equal to yes, and it's running this line here. Then what's happening, since this is also an if, it's actually, this is not running because having good day is not equal to no. And so this if and else are like it's like a sandwich with no toppings in the middle. And so what's happening here is, since this if isn't running, this else is running. That's what's happening. So it's saying, oh, you didn't put no here, so I'm going to run this else code because the if didn't run. It's making this like a little mini sandwich. And so these two, this if and else, are getting lumped in together. And what's happening here is we actually have two flow control choices. We have the original if, and then we have the second if else is making a second choice. We have two choices stacked on top of each other, which is not actually what we wanted to happen. Now, is it okay to write two ifs in a row? Absolutely, it's okay. It's okay to do that. Just make sure that you actually need to make two choices in your programming row. That's all. If you only need to make one choice, if only one decision needs to be made in terms of flow control, then use if, else, if, and else. If your program genuinely needs to make two decisions quickly in a row, go ahead and write two if statements in a row. That's fine. There's nothing wrong with doing that. I just want to be clear that like this, if you are only making one flow control choice, the best way to write it is by using this if, else construction, not having kind of mutually exclusive if statements, because then you're going to be running multiple checks and you may only need to run one check. That's all.
Nathan, there are a couple questions in the chat.
Yeah, there's a question I see at the bottom here. Cassandra asks, how come it doesn't do anything if we answer no? So in this case, if we answer no, then the else is not going to run because the else is associated with this, this if right here. So if we get a no here, then the else code doesn't need to run because it sees that something else was true here. And so the else doesn't run in that circumstance if we put a no. Remember, else only runs if none of the other options above run. But in this case, if we put no, this option will run. And so this second one will not run. Kara asked a question, so would indenting else under the second prevent that? So putting else, oh, the else has to be, you couldn't put an else, like an indented else here. I'm not sure what Python would do if you do that, but that's not the proper way to write it. The else has to be at the same level of indentation as the if above. And that would be an interesting thing. It's one of those things, what will Python do? You could give it a shot and see what Python does. But usually the else, the idea is that the else has to come after an if statement so that it will execute if the if statement does not execute. Yeah. Okay. Let's take a look at some loops. We've got some time here to do some loops. We're going to look at loops, which are a little bit different. We've been looking at these kind of tree structures where it's like option A, option B, option C, and we're picking one off the menu. Now what we're going to look at is how do we repeat a thing like a certain number of times or just like keep doing something over and over. And so you may remember before we had like if homework equals true, then complete a homework assignment, check if homework equals true. That was a kind of like a loop structure. We're going to do something like that. And so that looks like a while statement, and it's something like this. While condition is true, take this action, okay? And so we can, I've got an example here that looks like this. We're going to ask the user to guess a number. The user is going to input a guess. We're going to evaluate that guess. If the guess that the user has guessed is wrong, we're going to tell them to guess again, and they're going to input a guess. And so this is kind of like a loop right here. We're going to check to see constantly, has the user guessed the number? A little bit of a guessing game we have here. Once the guess is correct, we're going to break out of our loop and we're going to print a congratulations message to the user, right? And so that's the idea here. Here's how this would work in practice. We create a variable called secret number. Here, I'm going to create it. I'm going to make it a string. I'm going to use the string function here. I could also write this like just like that. That would be the same thing. We know it's a string because it has single quotes on both sides. Or you can use the stir function to turn it into a string. In this case, we're going to define the secret number ahead of time as 4. We could also import a module, and I'll show you a program later in the course where we create a random number. But in this case, we're going to define it ahead of time. And then we're going to ask the user, we're going to tell the user, I'm thinking of a number between 1 and 10. Can you guess it? And then we're going to store that in a variable called guess. And then here's the flow control. Here's the while loop. While the guess does not equal the secret number, we're going to have the user input a new value for guess. by saying, nope, guess again. And so this is going to essentially loop over and over. It's going to check and it's going to say, is the guess equal to the secret number? If it's not, then it's going to say, nope, guess again. And as soon as the guess is equal to the secret number, this loop is going to exit out. It's going to stop running the code that's here, and it's going to print out, you guess the secret number, and then we're going to concatenate the secret number here. Now, the reason, again, that I've made the secret number a string is for a couple reasons. One, we need to do this comparison between the guess that comes in, the input, and the secret number. That'll be a lot easier because we know the input function turns everything into a string. It'll be a lot easier if we're working with the string when we make that comparison. Otherwise, we'll have to change it into a string before we do the comparison real quick. The other reason why I'm making the secret number a string here is because it makes this final concatenation here a little bit easier. And remember, we can also do with this final concatenation, we could do an F string as well. But let's run this code. I'm thinking of a number between 1 and 10, and so that they can put in anything they want. It doesn't have to be a number between 1 and 10, but the idea is they can put in whatever they want until they hit that secret number, and then it's going to say you guess the secret number, and it's 4. And so that's basically the concept of using a while loop. Now, everybody who has ever programs for a while eventually writes one of these while loop things that never ends. It's called an infinite loop, and you'll write one. It's only a matter of time. And so I'm going to tell you what you do in a Jupyter notebook if that happens to you accidentally create a while loop that goes on and on forever. And so I have a loop here. It says while true. And so it's obviously a condition that's not going to be untrue because I have nothing here to change the condition into a false. So this loop is going to print endlessly. So when I run this code, it's going to just print oh no's for days. It's still going. We see the asterisk up here. This code is still running. It's still printing oh no's. And so how do we stop this runaway while loop? You have a couple options. You can select the code cell in question and then go to kernel up here and then interrupt, and that will stop. See, now I have a number. The code has stopped. The other way to stop this while loop is that you can tap on the code runaway code cell and press the I for interrupt key twice. And if you press I twice, that will interrupt the loop that is going, and it will stop it from going away like crazy. And so another useful tip is if your whole screen is now filled with stuff and you want to kind of get it off the screen, anytime you run a code cell and you want to remove kind of the outputs of that code cell, you can click on the cell in question and then go to cell and then current outputs and then clear, and it will clear the output of that current cell. Another thing you can do is you can go to cell and you can go to all outputs clear, and it will clear the outputs for every single cell in the notebook. That's the last thing I do before I share these notebooks with you all, is I clear all the outputs so it's nice and neat and it's ready to run for the first time. Should we jump into a repeating while loop? All right, this is a little bit more complicated, but we'll jump into it and then I'll let you all go. So this is basically a repeating while loop, and I'm going to show you an easier way just below. But this is kind of important for understanding what's happening in the next example. And so we can do a while loop that repeats a certain number of times. So not just until this thing is true, but like repeat 3 times, let's say. So we can create a variable here. We call it I. That's pretty common for programming by convention. It's usually called I. We can call it whatever we want, though. We're going to say I is equal to 0. And then the while loop is going to say, well, I is less than 3. We're going to print out the current version of I. And then we're going to add 1 to I each time. And so each time we print the current value of I, and then we add 1 to I each time. And that's going to essentially print out. It's going to start at 0, and it's going to go to 1, and it's going to go to 2. Once it gets to 3, we're not going to print out I anymore. And it's the program is going to come to a close. We can do a similar construction with something like this. For I in range 3, print I. This is going to do the exact same thing. 0, 1, 2. Once it gets to 3, it's going to stop. And so this is just an abbreviated way, or this is just an abbreviated way for doing this kind of loops. It allows us to make this simpler. Again, this I here could be whatever we want. We could call it for, let's do iteration or something. This iteration. And it's just a variable that's being created for the moment to kind of store what number of loop that we're in. Okay, I'm going to pause there. We're at 5:15. You've got a little bit of homework to do. I've got several coding challenges in here, and there are answers on the bottom. So if you get stuck, you can check out the answers that are in the bottom of these coding challenges. Try and solve them. Some of them are pretty tricky. Things are getting a little bit more complicated with flow control. Yeah, I'm going to leave it there for today's session. Once again, apply for the TAP Institute, the Text Analysis Pedagogy Institute. It's a really fantastic institute, and we'd love to have you. Do take the application seriously. It's highly, like, there are tons of people that want to get into this thing. We have over 200 applications already. So take a little bit of time and tell us really why you want to go to the TAP Institute if you want to put together an application. Otherwise, I'll see you all on Friday for our next class. Thank you so much. As always, I'll hang out for a few minutes as long as I can to try and answer some questions. But thank you all, and I'll see you on Friday. Please do the practice. That's what's really going to help you learn. As always, the practice is where the magic happens. So thank you, and I'll take questions if folks want to ask questions. Input if why does user input if number have to be a string? Why can't it be an integer? That's just the way the Python input function works. So when it comes to Python, anytime you use that input function, it automatically turns it into a string, and that's the case. So if you don't want it to be a string, if you want it to be an integer, then you just have to make you have to change it over to the other kind. In this case, let's say they inputted an integer and you wanted it to be an integer, then you would use the int function, the int function, to make that change. Yeah, I'm wondering if there's a way to get it so that it would accept it as an integer off the bat. I'm not aware of a way to do that. But it shouldn't pose a significant problem if you're writing a code, as long as you know to make that change ahead of time. A lot of times I think the idea is that it wants everything to be put in as a string, because oftentimes the input that people are putting in as a string is something that's going to be responded to, like putting in a username or something like that. I suppose they could put something in the input function that automatically checks to see if it looks like an integer and then changes it. But people may find that also confusing if their variables are intended to be strings and now they're suddenly being turned into integers. It is a little bit confusing, and that's why I try to be clear about the difference between the integers and the strings up front, because you need to kind of realize that Python treats them differently with that plus operator and also with the print function. There's a question, the question is particularly about, let's look at the example here. I'll share screen again. Number 3, particularly about this one here. I guess. So let me see what the chat says here. Secret number equals int 4. You could certainly do it that way. Like you could do secret number, and then you could do int. Well, if it's already, you could write it like this. So let's say we assume that the secret number is an integer in this case. Then the only thing we have to keep in mind is when we do this guess here, we need to make sure that the secret number is being compared with a string. So we'd have to put an str here, which is fine. Change our code a little bit, but that's fine. We just need to make sure we're comparing apples to apples or oranges to oranges. So if the secret number is a integer here, then down here we need to turn it into a string, or alternatively, I guess we could say str of guess. Well, the guess is always, I guess, because it's an input, it's always going to be a string. So if we put an str here, then it can compare the secret number. But there's not really a significant difference whether we change it to a string here or we change it to a string here. The key is that we need to be comparing strings to strings or integers to integers. And if you want to change the code in a different way so that it makes the comparison how it should, you can certainly write it that way and change the logic a little bit. I find it's really difficult to know how people are going to solve programming problems. Like when I put together these challenges, people will oftentimes give me 10 different answers for the same coding challenge. And so play around with it, write it a different way, try different things. Ultimately, the best sign is obviously make sure there's no bugs, give it lots of input and make sure that you're getting out what you're expecting. And then the second thing is make sure when people look at the code that it's clear what's happening. That's the thing. Like it's okay to solve it in a slightly different way. Just make sure that it seems clear when people go to look at it. So if you have a different solution, give it a shot. Yeah, try it out. And certainly the solution I'm proffering here is not the only way to do this. And when you try the examples, I really struggled. I feel like sometimes I put together multiple, I think in the next lesson, I put here are 6 possible ways you could solve this problem, because there's a lot of ways to do it. So if you have a different approach, give it a shot. Other folks that may have questions? You're welcome, Chrissy. Thanks so much for joining us today. I'll see you on Friday, I hope. All right, I think we're gonna call this a close. Thank you so much, Eloise, for organizing everything. Thank you to Allison and to Amy for co-hosting and keeping making sure I can hear the chat, answering questions and making sure that I answer questions.